That's dues. Very good. Thank you, Rajesh. Appreciate it. Well, tonight's topic, as discussed previously, will be on RFI, radio frequency interference, and something I'm sure that all of us have experienced, at least on a few occasions. And if you can't hear me, let me know. I'll answer this and turn up the volume a little bit as I can. I'm glad I brought something to drink because it's all right. Can you hear me? I can. In the back, can you hear me? Okay, we will continue. So with RFI, here's what we're going to discuss. What is RFI? What causes RFI? Who is responsible for resolving issues with it? How to find RFI sources and eliminating RFI in your shack. So later on, I'll ask if anybody's currently experiencing RFI as time permits, but it is the conduction and radiation of radio frequency energy that causes an electronic or electrical device to produce noise that typically interferes with the function of an adjacent device, typically our ham radios. So we can be the recipient or we can be the one generating RFI with our radios. EMI and RFI are often used interchangeably, and EMI is actually any frequency of electrical noise, whereas RFI is a specific subset of the electrical noise on the EMI spectrum. The disturbance that affects the electrical circuit due to either electromagnetic conduction or electromagnetic, and I can see that my slides just didn't, Rajesh and I just don't communicate on the slides too well, so there you have it. My brain slips me as it would in this situation. But anyway, there's two causes for our RFI. Natural causes, that's something we've all experienced with, as you can see, the electrical storms, and then solar radiation, and then cosmic noise. And what I know about cosmic noise is zero, but the pictures look good, so I threw them up there so it'd have something nice to look at. But solar radiation, as you know, the sunspots on the sun affect our propagation. And so they can either help us having a band open or hinder us having a band shut. So that's the natural causes of RFI. And solar radiation can actually cause the noise levels to increase. Electrical storms that you've heard are static crashes. As the storms get close, when you're on the radio, you can actually hear them approaching and getting closer and louder. And your signal to noise ratio, your noise ratio will increase. And the key to operating a radio is to keep the difference between the noise ratio and the signal strength as far apart as possible. And that's how you can pick up the weaker signal. So you do not want noise in your station. Also, just about everything else that is electrical will cause RFI. Of note is the old-fashioned drill. So if you have an old-fashioned drill like this, the older equipment usually is more prone to causing RFI. But of note, these are wall warts, maybe a little bit difficult for you to see, but that's 21st century stuff, as is circuit boards. But the wall warts can go bad and cause you problems. So we'll get into later how to resolve that. But also outside sources such as our electrical services. And you can tell if a transformer is out by the noise level in your shack, it's going up. I run a mobile station, I can drive down the highway and I can tell which power poles are putting off RFI because I can watch the signals noise go up. I've also seen cars go by that will have motor issues and cause my noise floor to increase. So interesting phenomena. But as you can see, just about everything that's electronic in your house can cause you issues in the shack. I, for one, had recently had a fire alarm system causing me issues. I haven't had a lot, but I've had a few. If you want to really study this up in theory, which I'm a practical more type of operator. I like to get my hands and do it and find out what's causing it and that. But the theory is there. You can look it up, find a lot of information about the theoretical aspects of it. The responsibility lies with both the manufacturers as the primary source. And we know over the years that the equipment has gotten better and better and better. It's not like what it used to be. Years ago in our television sets, we used to see all kinds of interferences. But today with the LEDs, TVs and that, you hardly ever see it. Unless you're online and receiving the signal maybe through the internet once in a while, or even over the air, if you're doing the over the air, but cable is pretty clean. But over the air television today, you can still have interferences from storms. All right, and then the owners of the equipment, we also, as owners of this equipment, have the responsibility to be good neighbors and not cause interference to our neighbors. Years ago, we used to say, if you wanted to meet your neighbors, buy an amplifier. And there you go, and there they are. So when I moved into my home, they saw me bring in a tower and they saw me bring in this equipment, and I left it lay for quite a while and then start putting it up very slowly after I networked real closely with my neighbors. I'm in a non-HOA, having moved there from an HOA. So I was real interested in getting an antenna farm growing, and it has grown. But and as soon as I put the tower up, I had one neighbor complain. This was several years ago. Ironically, I was interfering with his cell phone. And so when he approached me, I said, "Ooh, that's not good." I said, "I can't be doing that," which is a true statement. I mean, the FCC says we can't do that. However, the chances of me interfering with his cell phone are pretty low. So I asked him, I said, "Well, when's this happening?" Oh, he says, "Quite often." I said, "Good." I said, "You tell me exactly when it's happening, because I keep a log of every time I'm on the air. And you come and we'll compare notes. And we'll see if I was on the air, and if so, then we'll take steps to resolve it." And that was the last I heard of him. So that's just a caveat on how sometimes to, go ahead, Henry.
Yeah, I want to point out, like cell phones, the part that this equipment operates under, I don't know which part it is, but by and large, most of this stuff is written into the rules that they have no protection. In other words, you interfere with them, their problem, really. I mean, it's not, it behooves you to negotiate with them, you know.
No,
Good neighbor.
but to be a good neighbor, you should.
Yeah,
Repeat the question for the people online.
I'm sorry?
Repeat the question for the people online.
Oh, thank you.
So, like I said, I just want to point this out, that most of this consumer equipment, it's built into FCC rules that they're not offered any protection.
Right, on certain pieces of equipment. And then other pieces of equipment, they are heavily covered. Yeah. Henry's question or point was that on certain ones of the cell phones, it's written into them that we are not responsible, that they're open circuitries, you might say. Is that correct, Henry? Is that the point?
Well, what the commission's saying is legally they have no recourse.
Yeah, legally is what Henry's saying, they have no recourse. they could take other means for recourse if they're that type of neighbor. We'll leave it there. All right? And so this is the referee, really. If you're interfering with somebody or somebody's interfering with you, the FCC gets involved, and it's the field engineering office that would try to help you. Now, I'm thinking that it used to be better than it is today, but we used to police ourselves better than we do today. And we have a lot of different style of operators today as opposed to yesteryear. But it's the same thing. The FCC will fine you or help you in resolving an issue. Say a neighbor has a fluorescent light or that. They're responsible for that if it's interfering with your.
Wasn't there a lady down in South Florida that had it might have been a diabetic machine, that insulin pump, and yeah, so whenever this ham guy got on the air, she said that it caused her insulin pump to go crazy.
That's not a good thing.
I don't know whatever got.
Yeah, I missed that one. What Henry was saying to those online, and thanks for joining us. Henry was saying that there was a lady in South Florida whose diabetic pump, insulin pump, was being interfered with by a ham radio operator, and we don't know really how that was resolved. But one question, go ahead.
They determined that there was a flaw with that bottle of insulin pump.
Okay, one speaker said that, one attendee said that there was an issue with the pump itself. So, but it's something that you need to be aware of, and if you're doing it, then you need to really seek help. And there's a lot of good minds in the club that can help you with situations like that if you haven't encountered them before. So it's a big topic. It's an interesting topic, to say the least. But how do we find it? Well, this is the old-fashioned way. We used to use AM radios with the antennas on it, and as you approach the source, the static on the AM radio, and it's still viable today, would increase, so you can kind of pinpoint the source. Then also, if it's something you suspect in your home, typical, go to your main power panel, start flipping breakers and see what circuits it's on, and then isolate that circuit and then find out which device it is. That's another way to do it. You can also use an RFI meter or detector, such as I have, if anybody wants to see it. This is a less expensive model, but they can range from $50 to $1,000, and but they're unique. I bought this one for one specific purpose, and that was to check the RF in my truck when I started running an amplifier, because I have a 3-inch coil in the back bed. Have you ever checked yours? I was just wondering. But anyway, we laugh because Todd has quite a antenna farm on his truck as well. But anyway, I wanted to know how much RF exposure I was getting. Turned out that when my cell phone got a call, there's more RF in my cab than when I'm putting out 500 watts on my ham radio. So that was the good news. But if you're going to get one, you need to make sure that it's on the frequencies you need to check. That's important. And then also I would suggest that have attenuation. Now my meter is a cheaper one. It doesn't have much attenuation, but you can get a little bit by this. And the reason for that is as you approach the source, then you can attenuate the signal and turn it down so that your meter's not totally pegged. So it's very useful for that. These are the type of devices, and you can see the one in the panel here. This has got a lot of bells and whistles. Of course, it's going to be the higher dollar one. These are just some of the names that are out there. There's quite a few of them, but you can see some of them, like this one has an attenuator, and so does this one. So they're a good device. Also, as we know as operators, depending upon the amount of power you're putting out of your shack, you have to do some sort of calculation on how much RF is in your shack. That's by FCC rules, and you can look that all up I'm sure everyone's aware of it, but if you're not, there you go. Okay, so now, how do we eliminate this is the key here. One of the keys is if you have it, how do you get rid of it? Now, other than lightning and things like that, how many here have experienced RFI in the shack where it caused you signal problems? Okay, well, it's interesting. Everybody has their own stories about it, and that's good to share them. We'll hopefully maybe have some time. But in my opinion, in a lot of Ham's opinion, a good grounding system is mandatory for the station. Now, having said that, I know hams that do not ground their stations. So there's two schools of thought on that. I personally like to ground the station. So this is my grounding system at home in my shack. And you can see there's a copper bus bar there. This strap coming out is a tinned copper strap, grounding strap made for grounding. I simply use hose clamps on there with 1/2 inch grounding straps to go to my equipment. Now, this is kind of a mess. You should really separate your cables a little better than that. But that is my grounding. One note, my desk, this is the best shack I've had. My desk is a solid core door, and I built it up with legs under it. But the key to this shack that I love the best is this is about a little over 1.5 feet, a separation from the wall, which is really nice if you're trying to get to cables. I like that. I never did that before. I was always pulling it out, going behind. But that's the first time I did this in the shack, and it was cool. On the outside where I bring, backing up, one too many, of course. You can see the pipe chase I use, simply the same way you would run an electrical circuit to the outside. But this is an electrical panel, sealed panel that I have on the outside. You can see this is a 8-foot grounding rod in the ground with a piece of copper pipe attached to it. I flattened part of it. These are 259 connectors, so that when I disconnect, my lightning protection is I disconnect everything. RF, I disconnect my grounds into the shack. And I also disconnect the AC so the house ground can't come into the radios. By regulation, I believe, city code, state code, whatever, maybe it's the National Electrical Code actually, states that the grounding rod systems for our radios need to be tied into the house grounding system, as I recall. Henry?
So, being an ex-broadcast engineer, I'll throw something out here. So we're grounding our station, right?
Yes?
And let me ask you this, when you look at the power cord to your radio.
Yes, sir.
You probably got external power supply or a Astron or something like that. Is there a third ground plug? Is there a grounding plug on it? Yes. So you plug that into the wall, correct?
Yes, sir.
Doesn't that create a ground loop? Yes. And what's a ground loop do?
Do you mean within the ground loop of the?
When you plug your power supply in, that goes to the chassis of the radio, right? You plug that into the wall, that safety ground goes all the way to the panel and goes to the electrical ground for the panel.
Yes.
Okay. So now
That's
you've
looped.
also taken your radio and you got an external ground that goes to the chassis and you grounded it to the earth's ground.
Right.
That's a ground loop.
Yes.
Okay.
Repeat
Yeah.
for them.
But go ahead.
No, repeat what he said. What?
I don't, does anybody see what I'm saying?
The ground loop is everything is grounded.
Huh?
Ground loop is everything grounded, right? Through the loop.
No. I'm talking about here's the point I'm trying to make.
Well, I'm missing it.
Okay.
I'm not seeing it on
Okay,
paper
I'm
to
gonna tell you how
drive.
to solve this.
Just a second, Henry.
Single
Just
point.
a second. Henry's talking about the ground loop, creating a ground loop. Go ahead.
So when you create a ground loop, you're creating an alternate path for current to flow. And when current starts flowing, this is causing, as Jerry is talking about,
The RFI.
RFI or EMI, whatever you want to call it. And this is a real big problem in AM broadcasting. Okay, so, again, when you ground your equipment in two different places, now you got circulating current.
Right.
Okay, so you've gone to all the trouble to ground your equipment. The way to avoid a ground loop is you need to lift the safety ground off of your equipment. Now, I know that's going to rub a lot of people the wrong way, but that's how it's done in broadcasting, because you cannot have two grounds on an equipment. A lot of people will say, well, two grounds is better than one. Sounds good to me. Well, electrically, it's not good because you created a ground loop, and a ground loop is a source of interference. What you want is a single point ground. Okay. So
What Henry is saying is you need a single point ground, and
I'm
then,
throwing this out, so trying to get people to think about this. Right.
but when you, by code, tie your house ground in to your radio grounds,
Right.
then you're still going to have a loop.
Until you lift the safety ground connection at the piece of equipment.
Right.
Is what Henry is saying. And so what that means you need to make sure of is that your antenna station ground is substantial enough to be the safety
Oh,
ground.
yeah. Yes.
Okay, and this point is not very well discussed in the National Electric Code or in ARRL stuff, but.
Okay, repeat it one more time so I can make sure I get it right, what you just said.
In order to have an effective and safe station, you need to have a single point ground.
A single point ground, Todd is pointing out, is the effective way.
And in order to not have ground loops, you need to go into your Astron power supply and either remove the little screw or cut the green wire so that you lift the power ground. But at the same time, there's a big ground lug on the back
For
of the power supply.
chassis ground.
To ground to the antenna ground.
Yeah.
And nowhere have I ever seen that discussed.
Yeah.
They all talk about ground loops, but nobody tells you
Yeah,
how to fix it.
The discussion is ground loops and that you isolate the grounds within the equipment and just have one chassis ground.
Right.
So that's basically what I've done.
Single point.
Single point grounding.
Is that the purpose of bonding all the grounds?
No. The key to this is you want a single point ground. You don't want current flowing through different nodes in your equipment. Now, Todd talked about going into your Astron power supply. Another thing you can do, which we did in broadcasting, go down to your local hardware store and you get these little green adapters that takes the ground off. That way you're not modifying your equipment. So again, I know this flies in the face of common sense. You know, two grounds are better than one. Well, not electrically designed.
Well, yeah. And basically that's the way mine is because my power supply is homebrewed without that. Okay, it plugs in and it's the two wires into the wall.
Okay.
But that's a good point. And I just
I know everybody
didn't
has,
think,
almost everybody has an Astron power supply.
yeah. No, I will show you mine sometime at the meeting. Go ahead, Steve.
I got telling myself, I was having an RF problem, so I got a wild idea. I took a ground rod and I sunk it through my slab all the way right underneath my radio station. And I connected everything up to that ground rod. And I said, I'm pretty damn smart. I said, I got a short ground and everything's fine. And then all of a sudden, I had a lightning strike. And it was a Yazoo radio at the time, it was a long time ago. And I sent it back over to California to fix it, and they said it's the worst radio they've ever seen in my life. And they couldn't understand how a radio got hit that bad. But what I didn't understand is, I didn't check, and my grounding from my can had a ground wire going into the ground, but I never followed that out to make sure that it was grounded. The idiots that installed it never put a ground rod in. So it was just a wire going into the top of the dirt. So anyway, when I figured that out and figured out how all this stuff works, just to make a short story, how it is, I had General come out and put a couple of ground rods in according to code. I disconnected everything from that ground, and to this day, when I work a radio, I have a little push-on plug. I disconnect everything. I have not had anything lost from lightning. And it's been like 15 years, nothing. What was happening is when that lightning came into the house,
Yeah, Steve,
learned the hard way.
Steve was,
It found the ground, it went through all my equipment and everything else, my refrigerator and everything in the damn house, out to my ground, and it just tore up everything in between.
right,
Now, the point Henry's trying to make is, that was what you call kind of a dual path there, well, RF does exactly the same thing. It's still electricity,
right,
so it does the same thing. So you want the ground outside your house, that's your main ground. And that connect isn't that right?
Single point.
Single point
The
ground.
single point ground, that's
That's
the
right.
key that you gotta.
yeah, single point ground,
And another thing I want to point out, talking about audio equipment, in broadcasting, another thing we do, how you got cables that go from one piece of equipment to another? Another trick is that we only tie the shield to one end. Okay, now I know people are gonna say, oh, wait a minute, that doesn't sound right, but the problem is when you have equipment in a rack, for example, well, the racks, if you're doing a single point ground system, it's all bonded to the rack, which goes to the single point.
yes,
So if you've got an interconnect cable going from unit A to unit B,
yeah,
and it's got shield on it,
yes,
well, you don't want to hook the shield at both ends.
right.
So are you getting the sense of what I'm talking about, single point ground?
Henry is talking about single point grounding if you have an equipment rack and you take all your equipment and ground it to different points. The whole cabinet is grounded anyway, so you want a single point coming off the cabinet to the ground, correct, Henry? Is that what you were saying? So single point grounding,
Now.
and I didn't think about it in depth that way,
let me
but
just say this. Don't do that to your coax cable.
no,
Okay, now I'm talking about like
Yes.
audio cables and
yes,
things that are being controlled.
not
and have a
RF
shield
cables.
on.
Yeah, okay. All right, good points, appreciate it. All right, this is how I connect underneath. That's there for the weather protection. There's more than that there now. And how we doing, Roger? What time are we leaving?
You're good.
Good, okay,
See you for a little bit.
Okay. okay, you want to keep your signal?
The next one.
Yeah,
I'll be quiet.
no, you're okay, Henry. That's a dialogue. This is what this is for. Wait till we pull up lightning and start talking about it sometime. All right? That's what we do as hams, right? Okay, you want to keep your signals and control cables as separated as possible. So in my shack where you saw it was kind of a mess, if I had RF, that would be one of the first things I would do. All right? Now you can, this goes back some time, but this is also possible in that you can shield equipment if you are getting RF into it from something. And that's simply meshes and things like that that have come on, new technology. We used to use some screens in the old days to get the equipment grounded, but it's not as necessary. I've never had to use anything like this. Back to the lightning, Steve was talking about earlier about a lightning strike he took in through the grounding system that he thought he had, and it actually was through these AC grounding, and which is common. That's why I isolate everything in electrical storms. I'm diligent about it. Now, I was taught that. It was hounded into me years ago, and that's what I do. My equipment's unhooked if I'm not on the air.
There's nothing better than an air gap.
Air gap is good.
Air gap is the absolute-
Sometimes a lot of air gap is good because there is the flux theory as well that you know about. All right, we won't go there. All right, how do you eliminate it in your shack if you have it on cables and that? We all know about the ferrite beads. So you can put them in different forms. There's open type and circulate them along cables, all pretty good. The one thing I put that up, the frequency up there, these are not all created equal. So they're 4 different frequencies. So you need to know what the formula of the ferrite bead is to know. We all seen them on the computer cords and that. That's exactly what that's for, is to choke off some of the RF. So, and there's some examples of air chokes that work on antennas. This one here is just simply rolling the coax cable. If you go out and look on the internet, how many coils you're supposed to have, what the spacing is supposed to be like on that. So when you do that research, if you do it, throw out the top, throw out the bottom, and go with the mean, because there's all kinds of theories out there that people will post. And then also, Henry mentioned the high-low band pass filters that we have on the FM down on the 2-meter rig down on the, I believe Steve got that. And those work quite nicely. Some can be a little pricey, but then I wanted to touch on common mode current, because this is probably what can happen the most in a shack, having RF come back on you when you have an antenna that's not working properly. And also, if you have a mobile station, this is very, very, very common. And there are devices out there that you can clamp onto a cable and actually measure the amount of common mode current coming back within the cable. And just another picture of it. I showed this once before, but we all know what the cable looks like. This slide may or may not work. This had some fly ends, and I didn't realize that it worked today. Rajesh, this didn't work last time, and it flew in. So we know the outer jacket and the insulator, which protects the outer braid from the center conductor, so that you don't get anything going back and forth between them. But what happens with common mode current, the RF goes out around the center conductor. So the center conductor has to be sized for the amount of power that you're putting in. Just like an electrical circuit in your house, the amperage determines the size, and the power on that determines the size of the gauge of the wire you want. So you can't use a 14 gauge when a 10 gauge is needed, or 12 gauge. But what happens is the RF goes out around the center conductor. The current returns on the inside of the braid. And then if you have a problem with your antenna or getting common mode current, it's going to be on the outside of the braid coming back towards you. And that's what can cause you some problems. All right. If you want to know more about RFI and the resources to get at the internet, of course, is a good place, but there's a lot of books out there on EMI troubleshooting and RF interference books. I think that Ham Guides to RFI is on the internet. Of course, the ARRL has a lot of information as well. So that's basically it. So who wants to tell us all about their, besides RF that you've had in your shack and you've resolved? What are some of the things that have caused you? Herb, go ahead.
I got two. I'll try to make it short.
Come up to the front, come up to the front. Come up to the front so people online can hear you.
Try to make it quick. I don't run out of time. It's not all that important, but.
No, I'm sure we all want to hear stories because we won't repeat them.
One of them has to do with my wife wanting some powerful lights in the kitchen. And I'm talking real bright, you know. She turns them on and you can forget about like the Saturday night net VHF stations that are way out there. This is with the TS2000 I've had for about 20 years. And I've got an outside antenna. I got a deed restricted community and I've got a clandestine type antenna. But anyway, you can forget about VHF if it's a faraway station that affects them until she turns the light out. So I was told it's the power supplies within the light emitting diodes within the fixture, right? Okay. The other one, I'll make this quick. This has to do with the garage door opener that everybody, well, most people have. So about 3 or 4 years ago, I bought a high-tech garage door opener, Wi-Fi enabled from your phone, the whole thing. Put a normal light bulb in it. It occurred to me that, wait a minute, why am I using a normal light bulb? Why don't I use an LED? A little 30-watt IKEA LED light. I did. I noticed my range went way back as I pulled up in the driveway. I used to go around the corner and open the garage door. From now on, I got to pull in front of the garage door. So I got to thinking, maybe something happened to my receiver. We're talking about a new garage door opener. No, it was the power supply within that little 30-watt light bulb. You wouldn't think it would affect the receiver, but it does. So if anybody decides to change their light bulb, you might want to go back to the old-fashioned light bulb. Yeah, Todd?
I have 150-watt LEDs in each of my headlight sockets, and when you turn those suckers off, it shuts off my FM receiver in my truck.
What the heck?
It totally wipes it out. It's amazing. It's like, go figure. Okay,
So how are you going to solve that?
don't listen to the radio.
Okay. He said his radio shut off with his headlights. Okay. Go ahead.
I have a stupid ass, it's of course, but used to say stupid ass is stupid does. I was so anxious to get on the air years ago operating on 10 meters HF, and I didn't bother to hook up a ground. And I had cordless phones light up. I had all kinds of lights light up in the house, just running 125 watts. Second question is, why do HF rigs have a grounding terminal on them, but VHF and UHF radios, mobiles used at home, don't have a ground plug on them?
Because they're
The answer
DC.
to don't work. They're mobile radio. And they're using the ground of the car? For instance, I have an Icon, 910H, it's a 100-watt dual band, all mode radio, and it has a built-in power supply. It does have the ground stud on the back, so you can connect it to your ground.
Yeah, Russ said he was asking why VHF, UHF radios didn't have a grounding lug.
Is it
Mine are all mode as well, and they have grounding rods. Is it, I can't remember. No, I think, don't the old Kenwoods have grounding lugs?
A base radio?
A base radio?
No, mobile even.
They use mobile or base.
Yeah,
Well, I mean, if you go by like a Kenwood TMV 71, which is common model now, there's no ground lug on that, even if you run it on the base. But the point is, typically, it's a 12-volt only radio.
Right.
So
yeah.
it doesn't, the point's not important.
Yeah.
You can add one if you want, I mean, I don't, you know.
Would be ground by doing that?
Anybody else want to add?
Well, my only comment is if you run balanced line, you don't have to worry about common node crossing.
No, you don't. Balanced line, that's key.
But they-
It's more than just an SWR. It's more than that. Balanced line.
I got $100, anybody can figure out how come I turn the HFB to the northwest, and I get sometimes up to an S9 signal. You can find it, it's $100 bill for you.
A noise,
You're pointing
a noise floor?
Northwest.
You talking about noise floor?
Huh?
Noise?
Yeah, just noise.
Noise.
Yeah,
Just turning it.
yeah, northwest.
It's a beam.
It's a beam.
There's something out there that you're picking it up.
Yeah, no kidding. I mean, you found what it is.
Now put some attenuation on it and go forward. Pick it up and go forward. Steve was saying that he turns his beam a certain direction and his noise floor goes off scale almost. So
I know some, Todd got something to do with JEA.
it's probably towards his place, but
I had one of my lineman friends put a faulty insulator on your transformer.
That's it. It's gotta be it.
you're gonna need a directional antenna to find that one, but
I have a directional antenna.
no, ground mounted so you can go at it and find out where it is, right?
Yeah. There's so much interference and stuff around. I could go halfway all around Jacksonville.
And then you're gonna need to attenuate it, right?
I'll pay somebody $100 a time.
All right, Larry, and then we'll close her out.
I've got an unusual problem with, I've had it for a while here. My heating and air conditioning on the HVAC system. When it kicks on, the compressor and the air handler kick on, I get on 15 meters over, I get a birdie about every 20 kilograms. Only on 15 meters, not.
Well,
So how old is this system?
It's, the reason I can tell you exactly because I'm getting it replaced next week. It's 14 years old.
Okay. Well, a lot of the newer systems, and this is in refrigerators, and believe it or not, dryers now, have pulse width modulated compressors.
well, Henry's talking, but go ahead.
So, me personally, I like the old Maytag that goes back 20 years.
Yeah, they last longer. Larry was pointing out that on his furnace, the motor, when it kicks in, gives him harmonics on 15 meters, was it?
Yeah, only on
Well-
15. A lot of those,
You may be able to choke that off, but if you're replacing it,
A lot of those units have variable speed drives on the evaporator boiler, which derives a speed signal from the pressure that the system is operating at. So it adjusts the efficiency of your system by monitoring the pressure. And use a variable speed drive to control that evaporator drive motor. Plus, a lot of the compressors that stay in town are what they call scroll compressors, and they too are variable speed.
Yep.
And so the variable speed unit will create RF. So,
Everything's gotta have a computer, it's gotta have a PDM module, and everything is getting complicated.
Henry's saying about how the electronics are getting so complicated.
Without an electric element.
my washing machine, we're talking about washing machines, they have basically gone to a DC motor.
Yeah.
They have gone to a DC drive motor and they control it electronically. Noise making.
Yeah, okay. Well, very good. Thank you all for your attention. Appreciate it.
Thank you.
Thank you, Harry. You look so serious on the TV monitor. You don't look so serious in person here, but on the monitor you look real serious.
I do. Was there a number up there on it?
Thank you, Jerry.
Yeah, you're welcome.
Welcome.
Where's Roger?
Question, Tom?
I need
He took
to
off?
make a couple comments about
I want
field
to
day.
get mine.
Okay, go ahead. You want to come up here?
Yes, so that other people can hear me too. So everybody can enjoy me.
We love you.
Field day, I think it's 25th and 26th of June, the fourth weekend of the month. It's my favorite time of the year, sweating, playing with radio gear. I'm starting to get things set up. I have applied for a special event call sign. Our usual K4D was taken like about 8 months ago. So we're going to have a different one, but we will have one. I'm going to be making my official request to Peter in the next day or so. I'm hoping to have a huge group of people having a lot of fun playing with radios, and I can't wait. Field Day is my favorite ham radio social event, if you will. And I haven't figured out exactly just how big and stupid my radio station's going to be this year. I try to up it a notch every year. And after last year running 1,100 watts on batteries, I'm not sure what I'm going to do to make it bigger and stupider, but I'm working on it. So, Field Day, let's do it.
Yeah, man.
All right.
So I will talk to the major biggers and getting the Salvation Army out there for dinner like we did last year. All right, Billy, let's do the 50-50.
3 prizes tonight. First one is ARL mug, courtesy of Larry, P4LWA.
She had the little girl do it.
And
I thought we were going to have some cookies.
what's the number of that ticket? 115. Need the ticket 115.
1115.
All right, second place. Roll for us here. What do we got?
816-104.
104.
Actually, I have that. I brought that, so
All right.
I declined. We got 095.
095.
There you go.
Okay, 095. And first prize is going to be for $25. Okay, good. $25. When I do it. Take that number back.
You can't win if you pick your number.
We got 107.
107. Got 107. All right.
Yeah, John's got it twice in a row.
If I were you, I'd give it back.
Thank you guys for coming out. We'll see you. Hold on, what's up?
Try to come over here to see Mike, but you.
Yep, if you're gonna be out Saturday, to help us out, please come over and see Mike. Tom?
One more thing.
Tom, the battery weirdo's got some new toys that he wants to show off. Got some lithium ion batteries that I found a source for. And if you're interested in batteries like I am, come by and see them. I got them in the ammo can over here. Yeah. The police officers kind of gave me a funny look when I carried a 40-millimeter grenade can.
Y'all take care. Have a wonderful day and happy Easter. You guys want to do your appreciation next month? Did you guys were talking about it?
We don't even do that right now. Okay,
Huh?
one second. We stop recording.
We could. So we want something real short.